Hi guys, welcome back to the channel. Jag here, and in today's class we're going to continue with our Science 10 content, and the topic is going to be on the synthesis and the decomposition reactions, and this is within the chemistry unit. Alright, so with that, let's get started. I'm going to take some questions from this book. This is actually the exercise and homework book. It's the Ontario Science 10, the McGraw-Hill Ryerson. And the reason I like this book is basically it gives you a lot of different practice questions that you can try at home, especially if you already did all the questions within the textbook. Okay, so first we're going to start off with the synthesis reactions. All right, and let me read out the question here. It says complete and balance the following synthesis reactions and all products are solids. Okay, so let's try this one. Okay, so I'm going to put example. So it is K, which is a solid, plus the Cl2, which is a gas. Okay, and again, make sure you do have your periodic table handy, okay? So that way you can check for any of the charges as well. So this is potassium plus chlorine, okay? And what we'll do is write out also like the word equations, okay? Just as practice here. So we're going to complete and balance the synthesis reactions. Okay, so remember in the synthesis reaction, I'm only forming one product here, okay? And I'm going to just put them together. So this is going to be potassium and the chlorine together. Make sure you're checking for the charges in the periodic table. Potassium has a charge of 1 plus. I'll put it on top here. And chlorine has a charge of 1 minus, okay? Now, if I see that the charges are the same here, they're just going to cancel out, okay? So I'll just put a line through it. And remember, if the charges are more than 1, you have to use the crossover method and cross the charges to the opposite side, okay? All right, so this is our equation here. And again, as soon as you write the equation, I have to make sure it is balanced, okay? So let's do that here. I have 1 potassium, there's 1 potassium, 2 chlorine on the reactant side. And again, the only way I can balance it is by putting the 2 in front, okay? I can't put the 2 at the back as a subscript, okay? So I'm going to put 2 here in front. So now I have 2 chlorine. However, you notice that now there are also 2 potassium on the product side here. I have to make sure I put a 2 in front. Okay, so just like this. And make sure you are practicing the balancing of all of these equations, okay? And if you still have some trouble, make sure you're actually drawing out the table. Okay, and after you do a lot of questions for balancing, you'll get really good at it and you won't have to draw out the table. All right, so let's go to the next question here. Okay, and again, here it says all the products are solid. Okay, so I should make sure actually that I put the solid, okay, in brackets, and this indicates the state of the compound or the element. You should always put the state down or the teacher will take off marks. All right, so let's try one more. Let's try this one. Also, let's actually write the word equation first. Let me take this off. So remember, I said we were just going to practice the word equation here. You should be able to write the skeleton equation as well as the word equation. So here I'm going to put potassium, okay, plus chlorine. Okay, so again, make sure you don't put chloride. I can also put, if I want, I can put chlorine gas like this. Okay, and it's forming one compound. That's how I know this is a synthesis reaction. I have KCl. Again, K is potassium. Okay, and Cl is chlorine. So remember, instead of writing chlorine, I have to make sure I'm adding the IDE ending. Okay, so it's going to be chloride. Okay, so just like this. All right, and this is the word equation. And you notice I'm writing everything in words, the reactants and the products. And I still have to show the arrow in the middle, okay, just to show that the products are being formed here. Are there any questions? Let's try one more example. Okay, so I'm going to actually take this off. Okay, and let's try this one. Okay, so I think we'll try doing like 2 examples for each type of reaction here. So Zn solid, okay, plus S8, and that's a solid. Okay, so now if you look here, Zn is zinc, and you can see I'm adding it to sulfur. Now you're probably wondering why there's an S8, okay, like an 8 subscript for sulfur. This is actually the most common stable form of sulfur. It's actually S8. It's not S2 or something like that. Sulfur is not diatomic, okay? And remember again, the word diatomic means I have two atoms of one element and they're attached together. So something like oxygen, nitrogen, fluorine, chlorine, bromine. These are all diatomic elements. When you write it by itself, I can't just write Cl. I have to make sure I write Cl2. Okay? So let's try this one. And I'm just going to put ZnS. Okay, now again, I would make sure I am checking my periodic table at the back. Okay, just in case you're not sure. Now zinc actually has just one charge. Okay, zinc is 2 plus. If you look at your periodic table here, I can see that sulfur is 2 minus. Okay, and there are trends in the periodic table as well. Okay, remember the group 7 halogens, they are all basically -1. And if you go to group 16 or group 6 here, all of them are -2. And then group 5 or 15, all the elements here will have a charge of -3. So sometimes it's good to actually remember some of these trends, okay? And zinc is transitional as an element. It's a transition metal. And it has only one charge here, okay? So I'm just going to write the charge on top. So 2 plus. And sulfur is 2 minus, okay? Again, the charges are the same here, and they are going to cancel out. So we'll just put a line through it. And this is my equation. I'm just going to make sure it is balanced, okay? So I have 8 atoms of sulfur on the reactant side. So what should I do here to make sure it's balanced? So look at the product side. I can only add the number in front, so I'm going to put an 8 in front. As soon as you put a number, okay, in front of the compound, that's going to change the number of atoms for each of these elements, okay? So I can see I have 8 for the sulfur, 8 atoms, but I also have 8 atoms of zinc, okay? So I'm going to go back to the reactant side, and I'm going to put an 8 in front. And now I have 8 atoms of zinc on the reactant side, as well as 8 atoms of zinc on the product side, okay? And I can see that the sulfur is also balanced here with 8 atoms on both sides. Okay, does everyone see how to do that? Good, so this is the synthesis reaction. Let's actually write down the word equation here. So I'm going to just write zinc plus sulfur. Okay, so again, make sure you don't put sulfide. I'm just going to write plus sulfur. And it's forming ZnS. Okay, so again, this is zinc. S is sulfur, but I'm going to add the IDE ending to it because it's the non-metal. And it's going to become zinc sulfide. Okay? Good. So this is the synthesis reactions. So let's move on. Let's try a couple of examples for the decomposition reaction. Okay? So let's take this off. Alright, and again, we are going to try the word equation as well. So I'm going to pick some examples from this homework book. So let's try this one. So this is Cu, 2, and O, okay? And it's a solid. Okay, so I'm going to read this out loud actually, okay? So it says complete and balance each of the following decomposition reactions and note that all the metal products are solids and any remaining products are gases, okay? So again, I should remember that anytime you have like a metal by itself, like an element, it is actually always a solid, okay? So let's try this one, okay? So I have copper and oxygen, okay? And we will write the word equation for this, okay? Because I have to remember that copper is a transition metal. It has more than one charge, okay? And you have to put the charges in brackets as Roman numerals. Okay, so if I'm going to do the decomposition reaction, I just have to remember, okay, that this compound as a reactant, it just breaks into its elements, okay? And it's going to break into a copper and oxygen. Oxygen is diatomic, okay? So make sure you're putting O2. All right, so I have something like this, okay? We should put the states down actually. Oxygen is a gas and copper is a metal. So by itself, it's just going to be a solid, okay? So remember again, we are not done here, okay? I have to make sure, double check to make sure that the equation is balanced. If it's not balanced, then I just leave it like this. The teacher will take off marks, okay? So here I have actually 2 copper. Let's try with oxygen. There are 2 oxygen on the product side. There is 1 oxygen. Because I don't see any numbers beside the oxygen atom, there is only 1 atom of oxygen. So I'm going to put a 2 in front here. So now you can see as soon as I put a 2 in front, I have 2 oxygens on the reactant side. And this is actually, so let's write 2 oxygen. I'll just put 2O. On this side, there's also 2O. Okay? If I look over here on the product side, there's actually 1 copper. Okay? On this side, I have 2 times 2. I have 4 copper atoms on the reactant side. Make sure you are actually multiplying, okay? As soon as you write down the coefficient, I have to multiply it by the subscript to get the total number of atoms. Alright? And I have 4 copper atoms on the reactant side. So what I'm going to do is I'm going to add 4 in front here. Okay? As soon as I add a 4 in front of the copper, now there are 4 atoms of copper on the product side. I'm canceling it and I'm putting 4. Okay, so this is actually the balanced equation for the copper oxide. So I'm going to take this off actually. Okay, and I said I just wanted to write down the word equation for this, and there is a reason. This is copper. And copper has a charge of 2 plus and 1 plus, okay? So I already know that from off the top of my head. You should be checking the periodic table, okay? Now if you look right beside the oxygen, how there's nothing there, there's actually a 1. So remember how we were using the crossover method? This 1 is actually coming from the copper. So the charge on the copper is actually 1 plus, okay? And the oxygen is 2 minus. So when you write this, I have to write copper 1 oxide, okay? And what it's breaking down into is just its elements, okay? So it's going to break down into copper, and I'm going to put plus oxygen gas. Okay, does everyone see that? So whenever you have one of the diatomic elements, I can always just, if I know it's a gas, I could just write gas in the word equation as well. Okay, are there any questions here? So this is basically the decomposition reaction. One more time, it just starts off with 1 reactant, and then the reactant just breaks down into its elements. Okay, so with that, let's try one more example here. That looks good. Okay, so let me just take this off. Okay, and again, I want us to practice the word equation for this as well. But let's write out the skeleton equation first. So I have Al, Cl3, and it's a solid. Okay, and again, it's just going to break down into its elements. So I know what the products are forming is going to be here, or which products form will be aluminum and chlorine. Again, chlorine is diatomic. I'm going to put Cl2 here, so don't just put Cl. And I do have to remember and memorize all the diatomic elements here. And if I just put Cl actually, I won't be able to balance the equation properly. Okay? So aluminum by itself is a solid. Okay? And chlorine is basically a gas. Okay? The question also just tells you that. Okay? It says all metal products are solids, and any of the remaining products are going to be gases. Okay? So I broke down my reactant into its elements. And now I'm going to just make sure that it is balanced here so the teacher doesn't take off marks. Okay, so let's start off here with chlorine. I have 3 chlorine, okay, on the reactant side, and I have 2 chlorine on the product side. And what I want to make sure that I do is use some even numbers here, okay, to balance the equation. So I'm going to put a 2 in front here, okay? And let's write out the number of atoms. I have 2 atoms of aluminum, okay, because I put 2 in front. And then 2 times 3, so 6 atoms of chlorine. Okay, does everybody see that? Okay, good. And then let's go to the product side here. I have 1 atom of aluminum. If you look at chlorine here, there's Cl2. I have 2 atoms of chlorine. Okay, and because I put 2 in front for the reactant side, I actually have 6 atoms of chlorine here. The way I can actually balance this is if I put a 3 in front of the chlorine, because I'm going to do 3 times 2, which is also 6 atoms of chlorine. Okay, I hope everyone sees that. So every time you're putting a number in front for the coefficient, make sure you are multiplying to get the total number of atoms. Okay, so this is just counting the number of atoms here. All right, and I can see for aluminum, I have 2 aluminum on the reactant side. I'm going to put a 2 in front. And that's going to make 2 atoms of aluminum on the product side. Okay, so I can see this is the balanced equation. Okay, the coefficients are 2, 2, and 3. Okay, again, if you do try to use like some really big numbers, I have to make sure I look at each of the coefficients. And if you can reduce the numbers, I would make sure I'm reducing it. Okay, but when I do balance my equation, I'm always starting with low coefficients like 2 or 3. Okay, and only if that doesn't work, then you should try using some bigger numbers. All right? Okay, so that looks good. And that brings this video to an end. Thank you so much for watching. Please make sure you do like, share, and subscribe to the channel. And I will see everyone next time. Thanks. Bye.